Let's do another one-tailed hypothesis, a problem using T. In this case, we're going the other direction in terms of tails. Consider the normal newborn rat weight of 7 grams, which is probably too heavy, but just go with me on this. A sample of 36 rats born from mothers who enjoy maternal massage. And what they actually do to these mother rats is they stroke them with new paintbrushes, just like you might find at Hobby Lobby. And it has this terribly relaxing, comforting effect. And it's been shown that the mothers themselves and their offspring actually do better physically just for the sake of having enjoyed that touch, if you will. So the rats that were born unto mothers that had that maternal massage show a mean weight of 8 grams with a standard deviation of 2. So they're heavier, which is kind of a good thing in animals. We hypothesize that the maternal massages increase the weight of the offspring. So what are the null and alternate hypotheses for a one-tailed test? So if you'll go down to the alternate, the weight among the rats with the massage mothers is greater than 7. So I'm predicting a direction here. It's going to increase their weight. Their weight among the rats is going to be greater than 7. What's the opposite of that? Less than or equal to 7. That's it. I just had to start off with the alternative first. Now, another thing is, on which side is the critical region going to be? Is it not going to be on the right side? It is going to be on the right side. So because that's the way the arrow is pointing. So that's one thing I can resolve right away. How many degrees of freedom will we have? Well, in the problem, we would have 35, but here's the thing. There are not 35 degrees of freedom in the table, and that's annoying. We're going to have to go down to 30. That's the convention, is you go down to the next number, not up to 40. So we'll go down to 30, and we'll talk about that here in a minute. So here's that critical region on the right side, and let's confirm it's 1.697. Now, here's my degrees of freedom. N minus 1, 36 minus 1 is 35, but that's not in the table. How annoying. So we'll have to go to 30. Let's check it out. 30 degrees of freedom, one tail, alpha of 05. The critical value is 1.697. So I did it right. It's 1.697. Let's do some math. A sample of 36 adorable rats born from mothers who enjoy the maternal massage shows a mean weight of 8 grams, standard deviation of 2, and please obtain place of the attained value of T on that distribution. So I just have to do some math. The standard deviation was 2. There were 36 rats. 2 over 6 is 0.33. Then I say, well, there was the sample mean weight was 8. The population mean weight was 7 divided by 0.33, and I'm just going to call that 3. It's probably 3.03, but just hold your nose. So 3 right there, and sure enough, I rejected the null hypothesis. Here's my critical value, and here's that obtained value. One-tailed alpha of 05. Again, really no decision to make. It's just right there as though I were looking at a scale. Can we do something else? What about an effect size? I just plug numbers in. The sample mean is 8. The population mean is 7. The standard deviation was 2. 1 over 2, of course, is 0.50. That's kind of a medium effect. So there is some kind of medium effect for having massaged the mothers, if you will. And it's a weird effect, but it's true. This is a lasting thing that they've shown, that attention, and I don't know what it is, promotes physical growth. It promotes brain development, just 50 things. It's a remarkable thing. Can we do something else? What about R squared? And again, I've decided to add a little bit of ornamentation on the T there because it doesn't actually spell out too explicitly whether we're talking about the obtained value. We are. So the obtained value, T squared obtained divided by the T squared obtained plus the degrees of freedom. The obtained value was 3. I'll repeat that down here. My degrees of freedom, I'm not using 30 this time. I'm using the actual number that it was, 36 minus 1. We only use the rounded degree of freedom, like going down to 30, when we're looking up the critical value. For other things, we use the actual degree of freedom. That's where 35 came from. You'll remember there were 36 rats in the study. This is 36 minus 1. So not too bad. 9 over 44, 0.205. Okay, what do I do with that? How do I interpret that number? Well, in that case, about 20.5% of the variance in the weight of the offspring rats, which is the dependent variable, was accounted for by the maternal massage, which was the independent variable. So about 20% of 20.5% of the variance in the weight in the offspring, which was the dependent variable, was accounted for by the maternal massage, which was the independent variable. Your text says treatment effect for independent variable and scores for dependent variable, but I'd like to be more specific, so I can actually ascertain that. Now, you'll notice the researchers kind of penalized here for a higher N. If we had only 9 rats that showed that effect, this would be a much larger effect size. My gosh, this would be 0.50. So you could argue that accounting for sample size is kind of baked in, if you will. But I really appreciate R squared. It's a fun, I don't want to say fun, but I think a terribly compelling thing to cite.